Hello all, welcome to the next subtopic of electrostatics, and in this topic we are going to learn about electric lines of forces. Electric lines of forces were introduced by Michael Faraday. This is just a line in which a force is acting on a test charge, and that is due to electric charge. So that's why it is called as electric lines of force. For example, if I say this is charge plus Q, this is charge minus Q. So what is going to be there? There will be a force of attraction. Let us not go in that case. This is what a test charge plus Q0. This is what a test charge plus Q0. So if I keep this plus Q0 very much near to the charge plus Q, so what is going to happen? There will be a repulsion from the plus Q, and there will be an attraction to by this minus Q, and the electric lines of force, it will be like this. So this is what a straight line. It will be towards minus Q. While if suppose the charge Q0 is placed over here, so this will be like this. The electric lines of forces are going to move like this. If suppose plus Q charge is placed here, so the electric lines of forces are going to it is going to move like this. Just like the magnetic lines of forces of a magnet, this is what North Pole, this is what a South Pole. Magnetic field is it is getting originated from the North Pole and getting terminated towards the South Pole. Similar to this magnetic field, there is what an electric field. So magnetic field is said to be originated from the North Pole and it is getting terminated towards the South Pole. The electric lines of forces also, it is originated from the plus Q charge and it will get terminated to the minus Q charge. So if suppose this is a plus Q charge, this is what a minus Q charge. Electric lines of forces will move from plus Q charge to the minus Q charge like this. So this is what an electric field means. This is what an electric field. Okay. So this is what electric lines of forces. This lines which I am drawing is what an electric lines of forces. So if suppose I keep a test charge on this electric lines of force, this is what test charge plus Q0. So this Q0 it will move by this line. It will move along this line. This is going to move along this line. So what is electric lines of forces? It is a line of force in which a unit test charge will flow. So let us see the definition of electric lines of force. The path along which a unit positive charge moves is called as a line of force. Okay. So this is what a line of force. If suppose I consider this as the line of force, I consider the two positions, the position A and this is what a position B. So if suppose I want to get the electric field at position A, what should I draw? I should draw a tangent. I should draw what a tangent. So this tangent is, it gives me the value of electric field at point A. If I draw a tangent at point B, it is going to give me an electric field at point B. So this is the direction of the electric field at point A. This is the direction of electric field at point B. So what do you think? It is a uniform electric field or a non-uniform electric field? Obviously, this is what a non-uniform electric field. Why the direction is like this? Because the electric lines of forces are moving like this. It means somewhere here there is what a plus Q charge and somewhere here there is what a minus Q charge. Okay. This is what the electric lines of forces at position A and this position is B. See, the electric lines of forces at position A and at position B both are different. Okay, so we can say electric field at position B, it is greater compared to the electric field at position A. So the power of electric field at position B is greater as compared to the power of electric field at position A. Why? Because electric lines of forces are very near to this. So here we can say density is high. What is high? Density is high. So here we can say density is high. And here at position A, the density is what? Low. So here the density is low, here the density is high. So we say the electric field intensity is more at position B because more number of lines of forces are present in a very small area. So in a very small space, more number of lines are present. This means electric field is greater compared to this electric field at position A. Let us learn about the characteristics of electric lines of forces. What are the characteristics of electric lines of forces? The first point is The lines of forces originate from a positive charge object and end on the negative charge object. So as I told you, suppose this was a plus q charge, then electric lines of forces are perpendicular to the charge, and for a plus q charge it will be originating. That means electric lines of forces are going to move away from the charge. So this is what electric lines of forces directions are. Electric lines of forces are moving away from the charge. While if suppose you consider charge minus q, so the electric lines of forces are also now the same thing, it is perpendicular to the surface of the charge. While in the case of negative charges, the electric lines of forces are moving towards the charge. It is moving towards the charge like this. Okay, so electric lines of forces are moving towards the charge. So what are lines of forces? The lines of forces originated from the positive charge object and end on the negative charge object. So this is what the characteristics of electric lines of forces. So this is a diagram from the book. So this is plus q charge. The electric lines of forces are originated from the plus q charge. It is directed away from the charge, and this minus q charge. Electric lines of forces are coming towards that charge. Okay. The next characteristic is the lines of forces neither intersect nor they meet each other. So suppose I draw a line of force like this. Suppose this was plus q charge, this minus q charge. The lines of forces are like this. The lines of forces are like this. These are the lines of forces. Now what does it mean? This means they neither intersect nor meet. So these are not intersecting like this. These lines of forces are not like this. They are not intersecting at this position. Why? If suppose I consider this first intersection, if I consider the first intersection, this is one line and this is another line. Suppose it is intersecting at point A. So the electric field lines are moving like this. I have to draw a tangent to get electric field. Electric field. I want to get electric field at this position. So electric field it will be in this direction. Electric field will be in this direction. Why? Because electric field will be in this direction. Why? Because of this line. The electric field will be in this direction, EA. Also, because of this line, the electric field will be in this direction. So there will be a two direction of same point. We will be getting two direction of electric field on a same point, which is not possible. That's why electric lines of forces they are not going to intersect nor they are going to meet. Okay, so let us understand the lines of forces neither intersect nor they meet each other, as it will mean that electric field has two directions at a single point. So at a single point, we won't will be getting two directions. Okay, so there should be only one direction. For example, like this. So we are there at position A, we are there at position B. At position A, we should get only one direction like this. This is what the direction EA. This is what the direction EB. Only one direction we should get. So moving to the next point, the lines of forces leave or terminate on the conductor normally. The lines of forces leave. So why they leave? If suppose this is what a negative charge conductor, so lines of forces, if suppose there is a positive charge conductor, the lines of forces are moving away. That means they are leaving the charge. They are moving away. Okay, they are moving away. So that means they are leaving the charge. They are terminating. Terminating means they are ending. So if suppose this was a negative minus q charge, so electric lines of forces are like this. It is getting terminated. Electric lines of forces are getting terminated like this. Electric lines of forces are getting terminated like this. Okay, so lines of forces they might leave or terminate on a conductor normally. What do you mean by the word normally? That means they should be perpendicular to the surface of the charge. Normal means perpendicular, so they should be perpendicular to the surface of the charge. Okay, so this is the meaning of the next point. Let us go to the next characteristics. The lines of forces they do not pass through the conductor. Lines of forces cannot pass through the conductor, but they can pass through insulator. So if they cannot pass through conductor, that means what? Electric field inside the conductor is zero. So they can pass through insulator. So if suppose there is a box, this is what a box, and this is what an electric field which is coming inside. That means here there are positive charges, because positive charges they electric field get leave from the positive charge, and again here there is some positive charges are there. That means electric field are getting away from the charge, and electric field is zero over here. Electric field is zero, that means this is what a conductor. So inside conductor electric field is zero because conductor is going to absorb all the electric field. Or if suppose it is what an insulator, if suppose there is what an insulator, then electric field lines they can cross this insulator. Electric field lines they can cross this insulator. Electric field lines they can cross. Obviously, there will be some damage to these electric lines of forces. Here, electric lines of forces are strong. Here, electric lines of forces are weak. Now, on what factor they will be getting weak? By a factor of K, where K is what dielectric constant. Where K is what dielectric constant, or epsilon R, that is what relative permittivity. Both are same. K and epsilon R both are same. Okay, so moving to the next characteristics, magnitude of electric intensity is proportional to the number of lines of force per unit area of the surface held perpendicular to the field. So what electric field it is proportional to? Electric field it is proportional to number of lines of force. Number of lines of force per unit area. So number of lines of force per unit area means what? Indirectly it is talking about density. Indirectly it is talking about density. So when electric field is more, electric field is more if suppose density is more. When density is more, that means electric field are very near to each other. Electric field are very near to each other. So we say density is more, electric field is more. So electric field is less. When electric field is less, when density is less. Density is less, that means what electric field are very away from each other. So we say electric field is less. So there is some example, there is some diagram in the book. So let us see what is the diagram is. So this is the diagram. So what we say, the electric field here, it is what EA. Electric field here, it is what suppose EB. So obviously EB it is greater than EA. Why? Because density at position B, density of what? Density of electric lines of forces. Density of electric lines of forces, it is greater compared to the density at position A. Density of what? Density of electric lines of forces again. Okay. So density means what? Density means number of lines of forces per unit area. Density means what? Number of lines of forces per unit area. And that should be perpendicular. That should be perpendicular to the field. Okay. So this is what all about the characteristics, that it depends on density. Okay, it depends on number of lines of force per unit area. If number of lines of force per unit area is more, that means electric field is more. If number of lines of force per unit area is less, that means electric field is less. Let us move to the next point. Again, the next point is all about density. So whenever the electric lines of forces are crowded in a region, the electric field is large. And whenever the electric lines of forces are not crowded, that means they are very far away from each other, the electric intensity, it is nothing but electric field intensity, we can say E is what? Small. If suppose the crowd, if it is not crowded, it is small. If it is crowded, it is what? Large. So electric lines of forces are widely separated from each other in a region where electric field intensity is small. So this is the example A and B again. So what do you say? You have to, this is what electric field at position A, and this is what position B suppose. So this is electric field intensity at position B, right? So which one is greater? Obviously we will say, sir, EA it is greater than EB. Why EA is greater than EB? Because here the density it is what more. Here the crowded, this is what more crowded, right? So this is what our first point. Electric lines of forces are crowded in a region where electric intensity is large. So here electric intensity is large, that's why the electric lines of forces are more crowded in this region. And here the electric intensity is small. So that means they are widely separated from each other. So these electric lines of forces are widely separated from each other. That means here electric field intensity is what? Small. Okay. So let us move to the next characteristics. The next characteristics is the lines of forces of an uniform electric field are parallel to each other and are parallel and are equally spaced. So I told you about uniform electric field. I told you about uniform electric field. So what uniform electric field means? Uniform electric field, how to draw? The parallel lines which are equal in length and which are equally spaced. So this is called as uniform electric field. So what is non-uniform electric field? Non-uniform electric field means what? Non-uniform electric field, that means if suppose the direction is same, but if suppose the length is different or uneven spacing is there, then this is called as non-uniform electric field. Okay, this is the uniform electric field. What is the criteria? They should be equally spaced, means the distance between the lines should be constant. The distance between the two electric lines should be constant, and they should be parallel to each other. So all lines of forces are parallel to each other. So lines of forces of a uniform electric field are parallel to each other and they are equally spaced. Okay, so the example is here. So this is an example of uniform electric field. Okay, now we all know that similar charges they attract each other while opposite charges they repel each other. Now what is the concept behind this? The concept behind this is nothing but the electric lines of forces. Electric lines of forces. So we'll talk about the first, the similar charges they repel each other. They repel each other. While opposite charges they attract each other. Similar charges they repel each other while opposite charges they attract each other. So if suppose the opposite charge I consider this was plus q, this was minus q. So electric lines of forces are going to originate. If suppose I say what is plus q charge? The plus q charge is nothing but the charges, electric lines of forces are perpendicular to the surface of the charge and they are away from the charge. They are away from the charge. So electric lines of forces are moving away from the charge in the case of plus q, while in the case of minus q, the electric lines of forces are getting terminated. The electric lines of forces are getting terminated. So if suppose if there is an origin, so this is what generation and this is what termination. So every generation needs what? Every generation needs termination. So this is what electric lines of forces are getting generated from plus Q, and it found something on which it can terminate. So this is what the electric lines of forces are now getting shifted in this direction. If suppose the charges are kept near each other, if the charges are kept near each other, the electric lines of forces are going to terminate towards the negative charge like this. The electric lines of forces are going to terminate. The electric lines of forces are going to terminate towards the negative charge. Okay, like this. But if suppose plus q and plus q charges they are kept very near to each other, what is going to happen is there won't will be finding any termination, but the electric lines of forces will get bent in this direction like this. The electric lines of forces will get bent like this, and here there will be a normal electric lines of forces. This is what a normal electric lines of forces, while there is some bending in this direction. Actually the electric lines of forces should be straight, but because of there is another electric lines of force in the same direction which is not accepting it. Actually it should be like this, the arrow it is away from each other like this, away from the charge. Okay, so that's why there is what mismatch. Here there is what generation. Again here there is what generation. So there is no termination. That means two generations are facing a force which is moving them away from each other. Actually, what is the normal case? This is the normal case. So in the universe, there's a property of the universe that each and every object they tend to move in the normal place, normal position. So this is what an abnormal case. This is what an abnormal case. So obviously they are going to experience a repulsive force. Now, the positive direction, the positive charge got its termination to the negative charge. That means they are going to experience an attractive force like this. Okay, they are going to experience an attractive force. Why? Because of this electric lines. Now this is not only electric lines, these are what electric lines of forces. That means there is a force present on this line. Because of this only there is what an attractive force or repulsive force present between the charges. Similarly, if you consider minus q, this is what a minus q charge, again this is what a minus q charge. So there will be a termination and the electric lines of forces again it is like this, there is what a termination like this. So electric lines of forces are again getting terminated like this. Electric lines of forces are again getting terminated like this. Okay. So again this is what an abnormal case, this is what an abnormal case. Electric lines of forces has to move away from each other. Okay, so that's why these are facing a repulsive force in order to get the stability like this. Okay, so the attractive force and repulsive force actually it is because of electric lines of forces. So this is what about the diagram. The positive and negative charges they are getting attracted towards each other, while the positive and negative charges they are getting repelled. Okay, so you mind this thing. Similar charges repel each other, while opposite charges they attract each other. Okay. So what is the next thing that we are going to learn is we are going to learn about electric flux. Okay. Thank you so much all of you for paying attention. Goodbye.